So in lesson 4, we're going to be covering the Pythagorean theorem as well as the distance formula. So let's just review these formulas really quickly and maybe go over one example of how to use them. You may remember that the Pythagorean theorem applies only to a right triangle. That is a triangle with a right angle. Okay, so this is right here. Let me zoom out a bit. This is a right triangle. And you'll notice that the hypotenuse of the triangle, okay, which is the longest side, the hypotenuse, in this triangle is labeled C, hypotenuse. And A and B are the two sides shorter than C. They are called the legs of the right triangle, okay? And this symbol, which looks like a little square, is a symbol for a right angle. So in a right triangle, we have the formula a squared plus b squared equals c squared. Notice that c is on its own side. There's no other terms on the side with c squared. So the length of the hypotenuse is c, and it's on the right side, so we square the length of the hypotenuse. That equals to the square of the length of one of the sides plus the square of the length of the other side. Okay. So it's always a squared plus b squared equals c squared, where c is the hypotenuse. Our distance formula is formulated in terms of coordinates. Okay, and it reads that d, which stands for distance, is equal to the square root of this entire expression. And this expression is x2 minus x1, or the difference in the x coordinates squared, plus y2 minus y1, or the difference in the y-coordinate squared. Well, let's get some idea of how we can use these formulas. We're going to look at this graph, which is on the worksheet for lesson 4, and we'll start by using the distance formula. Now, we're going to have to choose the points that we're going to find the distance between. Let's find the distance. Let's do the distance between A and B, okay, which is not a question on your worksheet. But A and B, we can find the distance between those two. Now, to use the distance formula, we've got to enumerate the coordinates of each of the points A and B. So what are the coordinates of point A? Remember that we're dealing with a coordinate plane. The horizontal line we call the x-axis, and the vertical line we call the y-axis. And the coordinates of A, as is true for all points, is an ordered pair, where we first put the coordinate of x, and then we put the coordinate of y. I think I'm going to do this in red ink, because I think it will stand out a little bit better against the black background here. So what is the x-coordinate, which comes first, of A? Well, we have to see where along the x-axis does A lie. We have to count back. Okay, we're going to the left of the origin. Remember, where the axes meet is known as the origin point. This is 0, 0. So now we're going to be counting along the x-axis to get to A. We have to go 1, 2, 3 units in the negative direction. So the x-coordinate of A is -3. What about the y-coordinate of A? Well, in order to do that, we've got to count along the y-axis. And to go to a line that runs through A, we've got to go 1 and 2 up. We're counting 2 up along the y-axis. That gives us this line which is going through A. So the y-coordinate for A is 2. Okay, so A, the coordinates of point A, is -3, 2. Let's do the same thing for B. Let's find the coordinates for point B. We have to find first the x-coordinate. It comes first. For B, it's only 1. We move 1 to the right, and that gives us the line that goes through B. So we've got 1, and then how far up on the y-axis is point B? Got to do 1, 2, 3, and 4. It's 4 points up in the positive or up direction. So 1, 4 are the coordinates for the y-axis. So let's call x coordinates, let's call the coordinates for A, let's say that this is x1, I should put a little 1 down there, and y1. Okay, so we've got x1 and y1 are the coordinates for A, and the coordinates for B are x2 comma y2. Okay, so now we can plug this all into the distance formula. So let me zoom out a little bit. Let's write our distance formula over here. So we have, and of course I'm not doing finding AC, you'll do that in class. I'm finding AB. So for now we'll just find AB. The distance is equal to, I'm just copying this from above, x2 minus x1 squared plus y2 minus y1 squared. Well, we go back to our graph. X2 is 1. We simply plug our numbers in. D is equal to the square root of x2. We look it up. It's 1. Minus, what's x1? We said that was negative 3. So 1 minus negative 3, the whole thing squared. Okay, we're plugging things in. Plus, we've got y2 here. We've got to find y2. Well, y2 is right here. y2 is 4. So let's plug in 4 minus y1, which is 2. 4 minus 2 squared. Okay, and let's simplify this now. So we have the square root of, the innermost parenthesis is just for the negative 3. One parenthesis outside of that gives us 1 minus negative 3. Now you may remember, if you have a negative and then you're subtracting a negative number, you have a minus sign and then a negative number, we can change both of these to plus signs. We'll go over that in class if anyone is finding that something that they don't remember. Okay, but we now have changes to 1 plus 3, which is 4 squared, okay, because that's what's inside the parentheses. We're still squaring it, plus what is 4 minus 2? That's 2 squared. So our distance is the square root of 4 squared plus 2 squared. But remember that this is sort of in a parenthesis by itself. You have to do this addition before you do the square root. Okay, so let's go ahead and let's do the addition, but before we can even do the addition, we've got to evaluate the squares first. Because remember, in the order of operation, exponentiation comes before addition. Okay? Please excuse my dear Aunt Sally. PEMDAS, you may remember that. Exponentiation comes before addition. So 4 squared we have to do first is 16. 2 squared we do next is 4. Now we add 16 plus 4, we get 20. We get D is equal to the square root of 20, and that is our answer. That is our distance. The distance is the square root of 20. That's how we use our distance formula. To do this with the Pythagorean theorem, we'd actually have to go back to here and draw a right triangle that has AB as its hypotenuse. Okay, so let's zoom in a little bit on this again, and let's remember that we're now going to try to do this using the Pythagorean theorem. We're going to draw a right triangle. This is one side. This is another side. Okay, these are sides we know the distance of because they're lying parallel to the x and the y axis. I'm sorry, I did a sloppy job with this line. And then finally, this is the distance we're interested in, the distance from A to B. It turns out to be the hypotenuse of a right triangle. So let's count and see what are the lengths of the two sides of this right triangle. Remember, the sides are adjacent to the right angle. So this side here is 1, 2, 3, 4 in length. So let me go ahead and label this with a length of 4. Okay, and this side here is 1, 2 in length. So let me label that with a length of 2. Well, remember, the two legs are A and B. The hypotenuse, which we don't know, is C. Okay, so we're going to use our formula, A squared plus B squared equals, let me bring that down a little bit, equals C squared. And now we're going to just plug in our A. By the way, it doesn't make a difference if I call 2A or 4A. as long as one of them is A and one of them is B. Okay, so the legs of the right triangle rather are always added together after they're squared. So let's go ahead and say 4 squared. So A is 4. We have 4 squared plus let B is 2 plus 2 squared equals C squared. This is the same thing as 16. 4 squared is 16. 2 squared is 4 equals C squared. That gives us 16 plus 4 is C squared. Well, 16 plus 4 is 20. So we've got 20 equals C squared. And finally, we take the square root of both sides, and we get the square root of 20 is equal to C. We get the same answer. The length of the hypotenuse, which is the distance from A to B, is the square root of 20. Note that when we take the square root of a square, in this case the square root of C squared, it gives us C. Okay, the square root and the square kind of cancel each other out. Okay, good. Well, I'm hoping that will help give us a head start on lesson 4.